Right, okay. Short date, please, and learn an objective. Okay, to identify equations of perpendicular lines. Right, so first of all, very briefly before we go on to the work, perpendicular lines are obviously lines where they cross. So this is very rough. They create right angles. Okay, they create right angles. Now, just remember with perpendicular lines, they don't actually have to have met yet either. Okay, I think some people tend to forget that. So these two lines are perpendicular because if you extended this, they would meet at a right angle. So I'd like to start off, we're going to just do the investigation on the top of page 234. Just a quick thing, just remember that because, for example, if you're doing the lines y equals 2x, because there's nothing here, they're all going to go through the origin, okay? So you don't need to put numbers in, just do that, and then you're going to go through the origin. You don't actually need the numbers, but use the squares on your paper to get the gradients, okay, to get the gradients. So have a go at that, please, okay? Page 234, the investigation, because I think it'll help us as we go through this work. All right, okay, pause the video while you do that, then press play when you're ready. Right, okay, let's have a little look. Hopefully you've got something like this, okay? So you can see here, so you can see it. I'll bring my ruler with me. I'm not sure that I did. Right, so you can see here, we've got this line. It's obviously negative, the negative half, and it's going there. We know it's a half because, again, it goes for every one it goes across, it goes half down, isn't it? One it goes half down, and again, it's the sort of 2 to 1, isn't it, like that? And the same here, 1 across, 2 up. So you can see these lines are perpendicular, the different color lines are perpendicular, okay? So hopefully you've got something like that. Again, hopefully we're able to work out these gradients fairly accurately, okay? Right, and what line, and sort of, but what we've got to remember, and when they get a bit trickier, when we have perpendicular lines. So say we had a perpendicular line to this red line, which isn't going, it isn't actually going through the same point. So we're going to be getting to the point where this perpendicular line here is going through this. Okay, so we have to find the equation about where it's crossing, sorry, where it would be crossing the y-axis, okay, finding that y-intercept. So that'll be the trickier part of today, okay. Right, okay, so the last video we watched, I think explained it really well, okay, explained it really well about how to find the perpendicular, okay, the equation for the perpendicular line. So remembering really, it's about that negative reciprocal. So if we've got 4, the negative reciprocal of that is, first up, it's going to be taking away, and then it's going to be a quarter. And we noticed that here, didn't we? When we did these, we've got a negative a half, and then the negative reciprocal of that is 2x, okay? We've got 3x, the negative reciprocal of that is minus a third x. And we've got a minus a quarter x, the negative reciprocal of that is 4, minus a quarter, 4, okay? And if we think about it, that does make sense, doesn't it? Because 4 is a positive gradient, minus 4 is a negative gradient, and where they, so it would be going in the right direction there. So it actually makes it fairly straightforward. So let's go through. So 2/3, again, all we have to do that is, again, we're going to turn that into, when we find the negative reciprocal, it's going to be a negative, and we're just going to swap those over, 3/2. Okay, we just swap them over like that. Okay, because if you think of this, this 4 is 4/1, isn't it? We're swapping. If we got a 5, it would be minus a fifth, because that's like 5/1. So as we were shown in the last video, it's the key here is knowing our reciprocal numbers. Okay, so again, if we got minus 1/3, that's going to be, sorry, I shouldn't be an equal sign, should I? The negative reciprocal for that will be 3. Okay, hopefully you're okay with that, with the negative reciprocals. Okay, really well explained in the last video. So therefore, if I wanted to find, say I've got this line here, y equals this equation 4x plus 2, and I want to find the perpendicular of that. Again, the only thing I need to worry about, okay, so y equals mx plus c. Now where if I just want to find any perpendicular line, it doesn't matter where it's where my y-intercept is. Okay, so c is kind of irrelevant if I'm just having to draw do any one I want. Okay, so all I have to do is find the negative reciprocal of that, so it'll be minus a quarter x plus 2, and it doesn't matter what I put here. Okay, it doesn't matter, because it doesn't matter where it goes through the y-intercept if I'm just told to write down any equation which is perpendicular to that. Okay, so so for example, if I wanted to find the perpendicular of y is equal to minus 5x plus 2, all I'm going to do is to write a perpendicular for that. Okay, a perpendicular equation. I'm going to turn that, this the negative becomes a positive, the 5 becomes a fifth x, and I can leave that plus 2. Okay, I could make that minus 3, it would still be fine. I could make it plus 10, because this point is just the y-intercept, isn't it? Okay, so where it's going through the y-axis. Okay. Right, so again, I think when you come to do the questions today, which are sort of finding pairs of perpendicular lines and writing equations, that'll be pretty straightforward. The difficulty comes when you'll have a question like this. Okay, so you have to write down the equation of a perpendicular line. Okay, a perpendicular of a line perpendicular to, so this is our equation, this is our line, but now it's telling us what it needs to pass through. So when it's being specific, this one's fairly straightforward actually, because naught, that's naught on the x-axis and 3 on the y-axis. So actually that the y-intercept of that is so the y-intercept is 3, isn't it? Okay, the y-intercept is 3. So on this one, okay, it would just be, so the perpendicular for this one would be, we're going to turn the positive to a negative, the 2 into a half, so we do the reciprocal, and then we know that this is the y-intercept, so it would be plus 3 is a positive 3, isn't it? Okay, so when x is 0, it's automatically on the y-intercept. So actually you would just keep that second part of the of your coordinate. Okay, but actually the ones that we're doing today in the book aren't like that. Okay, but just that's worth bearing in mind. Okay, and I think the third one of the examples that they showed where it was going through the line the coordinate x 0, 3, wasn't it? Okay, on the other video. Okay, right, so let's have a little look. What would let's go with so 2x minus 1. Let's do 2x minus 1 passing through 4, 0. Okay, 4, 0. Now we haven't got 0 on the x-axis, so this is where we have to calculate it. So it's actually the same as when we were calculating these with the parallel lines. Okay, so let's write out our equation first. Y equals mx plus c. Okay, so and we know the first part of our equation is going to be y equals, so we know this gradient is 2, so we're going to do the reciprocal, half x, and what we need to change then is c, isn't it? Because this is, we need to find the y-intercept, so this is the part we need to find is plus c. Okay, so this is the first part of our equation, we need to find that. Now from here, these are our coordinates, aren't they? Our coordinates are 4 and 0. Okay, so that's 4 on the x-axis, 0 on the y. So again, we substitute. Okay, we substitute like we did in the last lesson. So y becomes 0. Okay, then it becomes minus a half times 4. Okay, times 4, and that will give us our c. Okay, so a half to minus a half times 4 is equal to minus 2. Okay, a half times 4 is 2, and a minus times a positive is a minus, isn't it? Okay, so we're now to this part of our equation. Okay, because we're just substituting in our x and y variables. So using the balance method, we got a plus 2 there and plus 2 there. So that gives us 2, c is equal to 2. Okay, c is equal to 2. So all we have to do, this c here goes up to here, doesn't it? So our answer is, okay, our answer would be y equals a half minus a half x plus 2. Okay, plus 2. Okay, so it's quite tricky again. It's quite tricky. It's a little bit like the parallel ones yesterday. Okay, well, in fact, the same sort of method, isn't it? Let's try another one. Okay, let's try another one. So y is equal to 4x, just 4x in this case, passing through. In fact, let's do the other one. Y is equal to 3x minus 3x plus 4, passing through 6, 1. Passing through 6, 1. Okay, so again, write down the equation of a line perpendicular to, so this is our original line, okay, the equation for our original line, and our perpendicular has to pass through these coordinates. Okay, they have to pass through these coordinates. Okay, right, so again, we're going to write our equation mx plus c. So we know then for the first part, we know this minus 3x will become a positive third x. Isn't it? We've done our negative reciprocal, and this is what we have to find. We have to find c. Okay, so we have to find the y-intercept. Okay, now again, these are our coordinates 6, 1, and this is the x-axis, this is the y-axis. Okay, so we're just going to swap those around. So this becomes 1 is equal to a third times 6 plus c. Okay, so third times 6 is 2. 6 thirds would make 2, wouldn't it? Okay, so we've got 1 is equal to 2 plus c. So again, we have to take away 2 on both sides, don't we? Okay, on the balance method, 1 take away 2 is minus 1, and that would be c. So c is equal to minus 1. So we come up to here. So this is the bit we have to change, isn't it? So instead of a plus c, we have a minus 1. So we would change the sign as well. So it becomes minus 1. So our answer would be y equals 1/3 x minus 1. Okay, so that's our perpendicular line to this line here, which passes through these points. Okay, so that is a bit tricky. Feel free to watch this, especially this part of the video again, and even the other the video from Corbett Maths, again, the last part of that, if you're not too sure of these. Now, they're only, even on the full page, there's only one question on these, so these are really tricky. These are really tricky, and it's something you will definitely revisit in upper school. Okay, right, so today's work. You've done the investigation, so actually there's only 3 questions to do. You'll be absolutely fine on these two, I'm sure. This is the tricky one, okay, but give it a good go. Okay, I'm not going to be too worried if you can't do it, but give it a good go. And then it's a couple of really challenging extension questions for those of you who are finding this okay. All right, so I'll be really delighted, I'll be really pleased if you can do those, and delighted if you can give question 11 a really good go. Right, okay, good luck with those, everyone. Okay, bye.